Well, welcome to our latest episode of discovering about metaphysics, the human body, biochemistry, everything that we're going to uh, be discovering. There's a reason I find myself altering, what I'm doing. Somehow I find this more fascinating. I don't know, maybe it's because chemistry is my first love, but there's something else going on. My wife will tell you, uh, my beautiful wife Valerie, that I've been studying like a banshee lately, all with what I'm coming across, and you know what? I think it's got to do with me hitting 65. It's one of those things. Geez, you've already heard the expression. Geez, if I knew I was lived this long, I would have took better care of myself. Actually, after some of the stuff I'm reading, I'm lucky I'm still around 65. But I realize the metaphysical quality of food, minerals, stones, crystals. There is so much natural healing out there. Maybe that's what I should call this, natural healing. I don't know. That's where I find myself going. And I have so much I want to share with you. I've learned so much just recently. And believe me, trust me, as far as what I am learning, as I take you guys through this, I am keeping it extremely simple because as I delve into it, I'm going into it deep, and it gets very complicated very fast. And I have no intention of doing that to you guys. I'm going to keep it simple, but yet give you enough information to, maybe make some wise choices in your life as far as what you eat and, how you can prolong your life. But I will tell you this much: I need to get we need to go through some nomenclature because we're going to get the chemical stuff in just a little bit, nothing heavy, but yet you got to know what I'm talking about. As an example, acid and base. Okay? And we got to get that focused. There we go. Except he's going into focus. Hang on. Wait. It's frustrating. Anyway, we'll see and keep it in focus here for you. The definition of acid bases is the acid is a proton. Remember the proton? You use it at the protons in the nucleus of an atom. He's a proton donor. He likes to get rid of them. Or he's an electron acceptor. Either or. He'll be happy with either. A base does just the opposite. You'll take that base. He'll take that proton that an acid gives, or he likes to donate his electrons. So this is why one of the main things in chemistry is the formula. It's not even a formula. It's just a chemical reaction. Acid and a base, if you bring them together, yields a salt and water. Because these two, because they both do the opposite of what the other one does. They basically neutralize each other, and you're left with some kind of a salt. This is not necessarily the salt that we eat, and water. So you sit there and think, okay, I think everyone, has, and when people describe an acid, say how it's acidic. How acidic is it? Vinegar. Vinegar. Yes, it's an acid. It's a very weak acid. Hydrochloric acid, sulfuric acid is far more acidic. But the funny thing is, as we get into more chemicals in the human body and how they all work, you're going to hear that word acid a lot, and you think, what? I got acids in me? You sure do. Billions and trillions of them. Matter of fact, that's what your DNA is made out of. It's in the name. DNA is DNA, deoxynucleic acid, deoxyribose, nucleic acid. Your DNA is acid. It's not the kind of acid that chews up stuff, but it is acid. Anyway, so acid, base, there's a scale. And I think most people have heard of this at one time or another in their life. It's called pH. And it's a logarithmic scale from 0 to 14. And each one, we got 1, 2, 3, up to 7, then 8, 9, 10, up to 14. This is pure acid. This is pure base, with 7 being neutral. Which means it has no base to it. It has no acid in it. Each step, like between 0 and 1, and then 1, 2 is 10. This is a logarithmic scale. So it's just that twice, it's 10 times. 2 is more, actually it goes the other way. 6 is 10 times more acidic than 7. 5 is 10 times more acidic than 6. So when you get down here, you're really talking acid. Let's see if we get that back. There we go. And up to 14 here for base. Once again, now here, the difference between 7 and 8 is this is 10 times more base than here. 9 is 10 times more than 8. So when you get up to 14, and this is like lye and the like, which is extremely base, or basic as is sometimes abbreviated. So the reason this is even, well, it's got a lot to do, the main reason it's important is this between 7.3 and 7.4 is the pH of your blood. I'm telling you, if it goes out of this range, you're in trouble. This would be acidosis, and I forget what the other one's called. I don't remember offhand. But this is far more common, where the blood becomes a little, because it's going here, it's actually becoming more acidic. It's really becoming less basic, but it's working toward it. You don't want neutral, that's for sure. So at any rate, the body has mechanisms to keep that in that range, and it has to be in that range for many of the chemical reactions and enzymes in your body to work. So this is, if you're going to keep anything out of this, just remember your pH of your blood has to be between those two numbers. And when they take your blood, that's something they always check. Now, as far as getting into some of the chemicals, we just need to learn a little bit of terminology. Do you remember? Let's do this. This is probably the best way to do it. I don't know if you remember this from, I think it was the first video, maybe the second one. Carbon for hydrogen. This is methane. Methane gas. Okay? No big deal. If we add another C, let's add another one. Remember, each carbon has to have 4 bonds. This is actually propane. Okay? 3 carbons, and what? 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. But these don't have to be hydrogen. The moment I change this, I can make this an oxygen, which is attached to a hydrogen. You know what we got? As soon as you see an OH, and in fact, what will happen is that's often written as OH. Okay, like that. This is an alcohol. OH means alcohol. And you have tons of these in you, of all kinds. So, let's go back to that carbon. What if we... let's make that OH. This is no longer methane. This is methanol. Which is actually a racing fuel. Okay? Oh, I see we got out of focus here. There we go. And my little dog is down here by the tripod, and so all of a sudden the picture vibrates. It's her looking there. Yeah, well, hello, sweetie. That's my little girl. She's down here. Okay? Now, why can't we do this? Sure can. This is ethanol. This is what makes you drunk. Okay, guys? This is ethanol. And meth. Okay. When we get into different things, you will... Okay, there's different terms that you will see. Methyl. methyl. Ethyl. Propyl. And butyl. Each means something, which we'll get to in just a couple minutes. Ethanol, here it doesn't matter. We get only up to two, it doesn't matter. If you say ethanol, we know that the OH is attached to one of them, and the rest are filled with hydrogen. But let's do this. How about this? Because propyl, methyl means one, ethyl means two, propyl means three, butyl means four. All right? We have three carbons, so therefore it's propyl. This is an alcohol. This is propyl alcohol. Okay? Now, wait a minute. Does it matter which of the three the OH is on? You better believe it does. They come up with a mechanism to count which atom, which carbon atom the OH is attached to if there's three or more. So they count. They go 1, 2, 3. This is the second one, so they will call this 2-propyl alcohol. In other words, the alcohol part, which is the OH, is attached to this second carbon. If you have ever seen chemical names, you see the numbers, and you wonder what they mean, that's it. What if the OH is here? Well, technically, it could be called 1-propyl alcohol, because you always count from the side that would make that the smallest. Okay? And when it's one, you don't have to say it. You can just call it propyl alcohol, and it's understood that the OH is on the end. But so let's expand this out a little bit. 1, 2, 3, 4. 1, 2, 3, 4. But this is, you count from whatever is what's called the subgroup. You make that 1. So in this case, this would be 1. This would be 2. This would be 3. This would be 4. Okay? So we would have 4, which is butyl. 1, 2, 3, 4. This would be butyl alcohol. Oh, wait a minute. What if there's an OH here too? Could be. Then you count them both. You go 1, 3. In that case, then you got to put the 1. 1, 3, di, which means 2. 1, 3, dibutyl alcohol. 1, 3, 2 alcohols. 1, 3, dibutyl alcohol. If there was one here on the end here, it would be 1, 3, 4. Tributyl alcohol. Do you see how this works? So when you hear numbers, in case you never, what the hell does that mean? This is where it comes from. If you have let's do this. Okay, we already know it's butyl. Sorry. We already know it's butyl. Let's make this an H. Let's make this an H. Let's make this an H. Wait a minute, what the heck is this? This ain't, I don't see any OH. Well, that means it's not an alcohol. We got a butyl, 1, 2, 3, 4. 1, 2, 3. But with this C, actually, this would be written. This would be written as CH3, which is him. CH, which is him and him. Down here, CH3. Then CH2, because it's like that, CH3. This is butyl. One is a methyl. We have a methyl group attached to a butyl group. Do you see it? So what's this called? Can you see it here? Okay. This methyl group is attached to a second carbon of the butyl group. It would be called 2-methyl butane. I get a reason why it wasn't called butyl in a minute. Because the methyl group was attached to the second atom of the butyl group. What if I had I heard my little dog coming downstairs. What if I had this? Well, this just changed. This is no longer the case. I'm trying to give myself much room here. I apologize. This becomes CH2, CH3. This is an ethyl group. Ethyl is 2. This is CH2, CH3. This is the ethyl group. This hasn't changed. It's still butyl. This would be 2-ethyl butane. I hope you're starting to get it. How it's done. So if I was to say just to give you an idea, just so that you're not blown away. When I'm trying to think, I'm trying to think of an example. 2, 3, octane. 2, 3, hang on. 2, 3 dimethyl octane. What the hell is that? Well, an octane, we all know what octane is. That's what a component of gas that you burn in your car. Oct means 8. So, you have 1, 2, 3, 4, 5, 6, 7, 8. That's the octane. We have, and if we number them, 1, 2, 3, 4, 5, 6, 7, 8. At spots 2 and 3, we have a methyl group. There it is. The rest of them are all hydrogen. Okay, I'm not putting them in. I hope I'm not losing anyone here. It's really pretty simple. You could change this to, and I will, 2, 3 dimethyl 7 octanol. OL, when it ends in OL, that automatically means alcohol. And alcohol. So it'd be 2, 3 dimethyl. This stays the same, and on the 7th carbon, instead of having a hydrogen here, it's actually called a hydroxyl group, but we'll call it an alcohol group. Okay. Now and once again, I'm going to make it real simple here. I'm not going to draw major diagrams. We've all heard, and you may have heard the term. I know you've heard the term, and may have wondered what they really mean. And there's a reason why I went through all this, and that is omega-3. Okay, we've all heard it. Omega-3 oils, and there's omega-6 and 9, by the way, which are also important in human biochemistry. But omega-3 is definitely the best and most important. Well, what does it mean? Actually, it's very simple. In the case of the oils that we consume, I don't know if you remember, if you have a bunch of carbons in a row and each one of them has a hydrogen around it, that's called saturated. And unsaturated is where you have a double bond. Let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbons. And you all pretend they all have hydrogens around them, okay? But where did we go right here? 1, 2, 3. So in other words, there's nothing attached to these two, because each carbon can only have 4 bonds around it. The double bond is, sorry about that. The double bond is on the 3rd carbon. That's what makes it an omega-3. If that was a single, and instead it was on the 1, 2, 3, 4, 5, right, 1, 2, 3, 4, 5, 6, the double bond was here. If I remove, I got to put those. I would put those in. Now these two just got one. So on the sixth one, there's your omega-6. I don't know about you. Omega-3s are much, much, much better for you than omega-6, so you do need some omega-6. You would think it doesn't make any difference. So wait, here it's on the third, here it's on 6. That double bond. Why should it make a difference? It's because of the construction of the molecule, the geometry of it. It changes it. Everything, all your enzymes, proteins, and all that good stuff is based on the size and the shape of the molecules involved. And just to wrap up this one, I'm gonna if you go to a health food store and you look at the amino acids, which we're going to get into probably next after today's show, after today's video, and you'll see whatever name the amino acid is or chemical, you'll see L. Well, what the hell does that mean? Okay. The easiest way to explain this, I got an example here I want to show you. GLYCERALD. Glycerol, however you want to pronounce that. Sorry. I can't get it out. Can't get you back up. There we go. Okay. Here it is. Here's the formula for it. Double bond O with the hydrogen attached here. God! Sorry. Alright. With a hydrogen here and one of those hydroxyl groups there, and finally going down to CH2O with CH2OH. Now the other one, it's exactly the same here. All the way to here, except the OH is on this side and the H is on that side. You can sit there and say, aren't those the same exact thing? Yeah and no. This is called, I want to make sure I'm telling you this right. This is called D-glyceroldehyde. This is called L. It's called L because the H is on this side. You say, wait a minute, they're the same exact thing. All you got to do is turn them around. No, they don't work that way. Because if you you would have to turn the whole thing around, and then these would not be in the same place. So there's a name for this. I'm not even going to bother telling you what these two are kind of like mirror images of each other. But the fact is, in the human body, any place this happens, and this happens with a ton of chemicals that is inside your body, if there's a chance for if there's two versions of it, they're exactly the same, except these are reversed, what's attached to them. The human body is the L version that works. If your body was making this chemical and it made this, and it's a critical chemical, probably gonna die because this won't work in the human body. Yes, it might be found in nature, but this is what your body wants and needs, is the L. So that's why if you go to like a health food store, You look at the amino acids, it's chemical, they'll say L this, L that. That's what it is, because that's what's in there, not this, because that's what your body needs, not this, because this won't work. Very interesting. So, I think I'm going to end it there. I think the next show, next video, we're going to start talking about, I think amino acids should be next on the list, because they're so critical, they're so important. Some of them whether you probably just didn't know they were amino acids, and we'll get into the amino acids and find out what it is just exactly they really do. We'll see you in the next video.